Defining the Atom and Structure of the Nuclear Atom by Emily Hogan and Taylor Poirier. Early models of the atom. An atom is the smallest particle of an element that retains its identity in a chemical reaction. Many early scientists and philosophers observed the atom. Democritus was among the first scientists to study the atom and reasoned that atoms were individual and indestructible. Dalton used experimental methods to transform the ideas of Democritus into a scientific theory. The results of his studies are formed in Dalton's atomic theory. Dalton's atomic theory is the first theory to relate chemical changes to the events at the atomic level. The four parts of this theory are all elements are composed of tiny, indivisible parts called atoms. Atoms of the same element are identical. The atoms of one element are different from those of any other element. Atoms of different are identical. The atoms of one element are different from those of any other element. Atoms of different elements can physically mix together or can chemically combine in simple whole number ratios to form compounds. Chemical reactions occur when atoms are separated from each other, joined or rearranged in different combinations. Atoms of one element, however, are never changed into atoms of another element as a result of a chemical reaction. This picture helps you to get a better understanding of Dalton's atomic theory. Sizing up the atom. The average radius of most atoms is between 5 times 10 to the negative 11th meters and 2 to get a better understanding of Dalton's atomic theory. Sizing up the atom. The average radius of most atoms is between 5 times 10 to the negative 11th meters and 2 times 10 to the negative 10th meters. Although they are so small, atoms can be observed when using scanning electron microscopes. These electron microscopes are capable of such high magnification of atoms that atoms could be moved and arranged into patterns when in use. Subatomic particles. The three kinds of subatomic particles are electrons, protons, and neutrons. Electrons are negatively charged and were discovered by J.J. Thomson. Thomson performed experiments in which electric currents passed through gases at low pressure, filled the gases in a glass tube, and closed it with metal discs called electrodes. These electrodes had an electrical source. From this electricity, filled the gases in a glass tube and closed it with metal discs called electrodes. These electrodes had an electrical source. From this electricity, one electrode, the anode, gained a positive charge, and the other, the cathode, gained a negative charge. As a result, the cathode ray, a stream of electrons produced at the negative electrode of a tube containing a gas of a low pressure, was formed and traveled from the cathode to the anode. Cathode ray. The cathode ray is deflected by electrically charged metal plates. Thomson also found that cathode rays are attracted by opposite charges but repelled by similar charges. The following two pictures are examples of the cathode ray.
Positively charged subatomic particles are called protons. Each proton has a mass of about 1,840 times that of an electron. Evidence for a proton was found in 1886 when Eugene Goldstein observed a cathode ray tube and found rays traveling in that direction. In 1932, the English physicist James Chadwick confirmed the existence of yet another subatomic particle, the neutron. Neutrons are subatomic particles with no charge but with a mass nearly equal to that of a proton. Although protons and neutrons are exceedingly small, theoretical physicists believe that they are composed of yet smaller subnuclear particles called quarks. When subatomic particles were discovered, scientists wondered how the particles were put together in an atom. J.J. Thomson thought it likely that electrons were evenly distributed throughout an atom filled uniformly with positively charged material. Thomson made a model known as the plum pudding model, where electrons were stuck into a lump of positive charge, similar to raisins stuck in dough. In 1911, Rutherford and his co-workers wanted to test the existing plum pudding model of atomic structure, so they devised the gold foil experiment. Their tests used alpha particles, which are helium atoms that have lost their 2 electrons and have a double positive charge because of the 2 remaining protons. In the experiment, a narrow beam of alpha particles was directed at a very thin sheet of gold foil. Based on his experimental results, Rutherford suggested a new theory of the atom. He proposed that the atom is mostly empty space, thus explaining the lack of deflection of most of the alpha particles. He concluded that all of the positive charge and almost all of the mass are concentrated in a small region that has enough positive charge to account for the great deflection of some of the alpha particles. The Rutherford atomic model is known as the nuclear atom. In the nuclear atom, the protons and neutrons are located in the positively charged nucleus. The electrons are distributed around the nucleus and occupy almost all